So following on from yesterday, we are going to continue with quadratics, and we're going to look at basically getting information if you're given the graph of a quadratic in a certain way. Now I've just filled in example 3 and part of example 4 just to kind of save a bit of time, but I'll talk you through them. So example 3, first of all, basically if you remember from yesterday, the graph of x squared, which was that first one, that one, would like go through the origin. So basically if you've gone up 3 places, you'll basically put a plus 3 on the end because it's x squared plus 3. The next one, x squared minus 4, because it's been moved down 4 places, which is your y coordinate, is gone down to minus 4. And then the last one, remember it was upside down, it had a negative in front of it, so it's negative x squared, but it's been moved up 7 places, so it's plus 7. But again, we'll kind of talk about that in more detail like later on. But for example 4, what we're going to be doing is I've given you 2 quadratics, so one in blue and one in purple, and I've drawn them basically to save a bit of time, and there's some key information basically from these that we need. So the most important thing about a quadratic is called the turning point. So for both of these, I've drawn them in similar to yesterday, and you can see when the graph turns on itself and it goes back up the way. So this purple one comes down, it goes down to that negative 3, 2, and it goes back up on itself, and it's symmetrical. Same with this blue one, it goes down, it goes to that 1, 0, and then it comes back up on itself. Now, instead of drawing the graph and getting this information, basically what we're going to be doing is how do you get it if you're given the graph, like we're given that blue that I've underlined there, and that purple one there. So, the graph of y equals x minus 1 squared. Now, it's got a minimum turning point because it goes down to a minimum at, as we see from the graph, 1, 0. Now, both of these graphs also have got a line of symmetry. So they're symmetrical. So obviously this one here, that would be its line of symmetry there. Now all those points are going through the turning point. So basically what we say, it's got an axis of symmetry of x equals 1. So it matches the x coordinate of your turning point. So we just write x equals 1. Same with the purple one. So we've got x plus 3 all squared plus 2. So if you look at your graph, you can see the turning point. Again, it's minimum because it goes down to a minimum. It's at negative 3, 2. And again, you've got this axis of symmetry. Which basically we just say is x equals whatever the x coordinate is, which is negative 3 in this case. So when you're given your 2 graphs, basically what we're looking at is how do you get the information without actually drawing them. So if you're particular, if I look at this second one, if you look at your numbers, it's like a nice colour, pink. Okay, so if we look at the numbers in here, with relation to here, you can see that the number on the end is the exact same as that number. But when you've got a plus 3 in the middle, it becomes a minus 3. And that's kind of similar to the one above. We had a minus 1 in there, but it becomes a 1 out here. So basically it changes sign when it comes out. So if you're given this form, which we call completed square form, if you're given a quadratic that looks like that, you can basically get the turning point from it by getting the x coordinate and the y coordinate. So it's kind of a wee summary here, which I'll just highlight. So first of all, turning point is what we need. Axis of symmetry is basically just x equals your x coordinate. Again, we'll do some examples, I'll talk you through it. Minimum turning point, if it's a positive number at the front, and it's a maximum turning point if it's negative, and again, we'll do some examples and I will talk about that. Okay, so if we're given the graph, basically how do we get the 3 bits of information? So, first one. So we're given y equals x minus 5 all squared plus 6. So first of all, your turning point. Okay, your turning point. So we look at the numbers in here. So the most important thing is that when it's a negative in the bracket, when you're getting your turning point, again looking at that graph, it becomes 5. But the number on the end is the exact same. So for your x coordinate, the one with the x in the bracket, it changes sign. So for instance, like in this, a negative is now a positive number. And then a positive number. So if it said like plus 3, when you take that out, it becomes negative 3. So 3 things we're going to ask for is turning point. Next one is axis of symmetry. Now I kind of like to remember it as AOS, axis of symmetry, x equals. And it's just that number for your x coordinate. So whatever you've put there, it's there. Last thing, this is a minimum turning point. And again, when we look at the next couple of examples, we'll talk about how to know the difference between a minimum and a maximum. It's to do with the bracket. So there's no number in front of the squared bracket, so it's a minimum. Right, next one. So turning point. So again, we're looking inside your bracket. These two numbers here. That is a plus 2, so when that comes out, it becomes a minus 2. And then the number at the end is just the exact same. So that minus 4, just a minus 4. AOS x equals negative 2. So it matches that one. So that matches that. And again, minimum or min turning point, again, because there's no number in front of the bracket. However, this one you can see it does have a number in front of the bracket. So go to a turning point as before, nothing else changes. So it is a negative 1, so it becomes a 1. The number in the end is minus 2. AOS x equals, again, these two things need to match. So it's just 1. This one has got a maximum turning point. So basically, if it's that, it's a minimum turning point. But as soon as you put a negative in front of it, it basically makes it upside down. And it's a maximum turning point. So it would look like the graph would look like that. And its wee turning point here, for instance, would be 1, negative 2. Okay, last one. So this one you can see is in a funny order. So what I'm going to do, like we kind of did in straight lines, I'm going to switch it around. So what I need to do, instead of saying 1 plus 2, say 2 plus 1. So, turning point. Again, we're just looking inside your brackets. So these two numbers are important. Plus 3 becomes a negative 3. 5 is a 5. AOS x equals negative 3. Again, because it needs to match that number there. And again, this one's got a maximum turning point. Or max TP. Because of the fact it's got a negative at the front, like we said. So a screenshot of this, I put it on Teams as well. You're going to work through examples similar to this example 5, basically, today. So I'm going to give you the quadratic in this form, which is called completed square form. So basically it's something squared, plus or minus a number. And you're going to write down basically these 3 bits of information like I've done. So turning point, axis of symmetry, and if it's a max or minimum. So almost think of it as like 3 bullet points that you're doing for each question.